Hello, everybody, and welcome again to RAG Masters. I'm Neil Katz, a tech entrepreneur. With me, as always, Daniel Warfield.
Hello,
data
hello.
scientist, a RAG engineer in his own right, an online educator about all of these topics. And we're going to do a lot of online educating today. A big topic today, and kind of a undersung, I'm not sure hero is the right word, maybe villain, but when it comes to building RAG applications, literally the first step in any RAG application is parsing your document and extracting the information from it and trying to turn it into something that language models will eventually understand and do something smart with. And I feel like it's the unsung hero villain in any pipeline because it just doesn't get a lot of attention. But I think it's like and I'm going to use a different metaphor, original sin, because if you don't get it right, the rest of your RAG pipeline doesn't matter at all. It doesn't matter what your prompting strategy is, your chunking strategy is, like none of this is going to matter. What your vector database is, it just doesn't matter, because if you don't get the information out of your giant set of documents in the first place, which is often where RAG starts, it's garbage in and garbage out, and nothing else will work. So Absolutely. With that said, thank you, sir. Glad you agree. So Dan, you're going to walk us through today a lot of the different strategies that are available. There's some different softwares that are available. I do want to say on disclaimer, one of those softwares happens to be from iLevel.ai, the company that Daniel and I both work for. That's called X-ray. You'll see it as part of this talk today, but this is not a talk strictly about our product and about X-ray. It just happens to be we have a product that does this, but we're going to give you an overview of how these things work, and you'll see in like some real minute detail what the differences are in these technologies and which one might be right for your project. You'll have to decide. With that said, I will shut up. I want to learn some things, Daniel. Take us inside document parsing, especially for LlamaParse and RAG.
Yeah. All right. So to the slides. So this is about parsing, right? So what is parsing? I think most people know, but let's dot the I's and cross the T's. So you have a PDF, or you have a text file, or you have a Word file, which is a rich text file, or you have whatever. There's a billion types of files. You have to get those files. You have to get information in those files out of the document so that you can give it to a model. Basically, every model that you're using, there's some weird academia ones that are designed to work directly with, documents and things like that. But the vast majority of models that people are using on a daily basis, the cutting edge ones, they all need text. They all need information out of the document. So somehow we have to get our information out of our documents so that we can give them to a language model in something like RAG, right? And so it's kind of funny. I think that that original sin analogy is a really good one. RAG has progressed tremendously. We have this thing called advanced RAG. We have all these crazy ideas, but it's all built on top of parsing. If you don't get the documents, if you don't get the information out of the documents well, you can't give them to your advanced RAG approach to do anything, right? You have to get the information out. And if it's a bunch of gobbledygook, it doesn't matter how amazing or impressive your advanced RAG strategy is. Language models can only understand so much, right? If you can't understand it at all, it's very likely a language model will at least struggle, if not completely flop as well, right?
That's a real answer from a real test of a real system, by the way. I'm not going to mention which one, but that was some real gobbledygook, garbage in, garbage out that came from a production RAG system out there in the market. We won't name names, but it can go south.
It can, absolutely. So parsing is incredibly important. So I guess the natural question is, if you buy that, and it's funny because a lot of engineers, they don't buy that. Well, at least they don't think about it, right? It's easy to get caught up on the fancy AI, the new data science trends and stuff, but parsing is incredibly important. So if you buy that, which I really think you should, then the next question becomes, how do you choose the right parsing strategy? Because what's kind of interesting is, actually, this was by Neil. He asked some Reddit folks. He was kind of curious, what do you guys use for parsing? And Neil, I don't know if you want to.
I wanted to know. I was just interested in what, this was in the LangChain subreddit, and I just want to know of the devs out there, what are people using? Is there people coalesced essentially on a common best practice on how to do this? And if you bring up the slide again, you'll see the answer is no. Just a lot of there was like 57 answers. I think there's probably 30 different products or techniques that people mentioned, which was pretty eye-opening, actually, that everyone kind of had a homespun version of a thing. I I connect this thing to that thing and plug this thing to that thing, and I got this process, and then it's kind of been working for me. And then typically when I would follow up, not on the slide, but I'd follow up in the thread. Okay, cool. Is there an eval testing how these 4 different things work against each other? And the answer was generally no. Folks, there was like 1 or 2 had gone to that length, but mostly folks were, to your point, Daniel, they tried a thing. It seemed to kind of work okay for now, and they went with it. And maybe that's okay. But we're going to try to be a bit more exhaustive in this show, Daniel. So why don't you take it from there and maybe show us some of the options and how we should maybe think about how to test our way into this.
Absolutely. So that's exactly what we did. We played around with a few parsing strategies, and we want to dig into what they give us, like how do they deal with these documents. So this is a medical bill. It's not like a.
I just want to say this is it's a copy of a real medical bill, but all the information, all the PII has been taken out, even the names of the company and stuff. So don't worry, this is safe data, but it's a good example of a kind of document that's in the real world we have to deal with in RAG.
Yeah, so let's pass it through a few options. So one of the famous classic ones is PyPDF. And PyPDF is kind of an older parsing library, and it's kind of a mainstay in the community, and it's great for textual documents. But this isn't just a textual document. We have tables, we have complex formatting and things like that. And PyPDF essentially completely failed to extract some really kind of the essence, kind of the most important parts of this data. And the reason for that isn't because PyPDF sucks. It's because parsing is really hard. PDFs are kind of difficult to deal with. There's a lot of different file formats. So if we're dealing with just PDFs in these examples, PDFs is a complex file format with a lot of ways to encode data. And it's really hard to just get straight up text out, right? So PyPDF completely failed to take out some of these tables and represent them in a way that any language model could understand, because there's no content that comes out of PyPDF. Tesseract is an OCR strategy. So OCR being kind of computer vision-y type of stuff. You basically take your PDF and you turn it into an image. So you get rid of all of the text, essentially, and it's just an image of text. And then you apply OCR to the entire image to try to extract all that stuff out. And Tesseract did extract this table. So hunky-dory, great, we're amazing. But actually, and this is, this is the issue with parsing, it wasn't perfect. If you look really closely, and it's a little cut off on the side, but if you look really closely, it says exam date, proc cov, description mod, b part LDX, LF amount. So that's sort of the b part LDX if LF amount was supposed to be separate column names, but it didn't see, I guess, the vertical line. So they all got kind of smashed together. So you can imagine if you're a language model and you're trying to understand this and you haven't seen the original document and you're not a person, so you don't just kind of know everything about you don't have like all that prior knowledge really. And you look at this, it's probably really hard to figure out, how to separate this information out effectively. It's funny. I talk about parsing. It's almost hard to talk about because it's so obvious. But if you look at it, it's like you need to be able to get the information out effectively. And it's easy for humans to take advantage or to kind of take for granted their ability to see documents. But if you look at this example and you imagine you never saw the document in the first place, it's really hard to understand what's actually going on in just the text.
Yeah. And there's a couple other things here. I mean, some of the words are wrong. It says procedural cove instead of code.
Yeah.
I guess it's differentiating the columns, but then not really doing that in the rows. And look, maybe some language models will pick this up and be okay with it. It's they're getting better at taking something that's a little bit garbagey and doing something good with it. But there's definitely a lot of noise in how this was extracted. Yeah.
And then we can look at a different example, which is unstructured, which a lot of people said that they use a lot in the Reddit. That's one of the top ones that people use on a regular basis. LangChain.
Yeah, I was going to say it's the default in LangChain today. I don't think it was when LangChain started, but I believe now it's kind of built into LangChain. Unstructured is a separate company, but some of their libraries are now built into the LangChain ingester.
Yeah. We can actually see kind of a similar problem. Like we have exam date, proc code, description, mod, b, part dx amount as like kind of, then there's a vertical line in there. But, you know, again, imagine you never saw this document and you can't look at it. It's not on the right and you're a language model and you have to make sense of this. And someone asks, what was the body part that costs 1,600? You might be able to figure it out, right? It says neck and spine, so you might be able to do context clues. But wouldn't it be way better if you didn't have to use context clues and you could actually look at the table? Because what if it was like a B part Z? Like what if there was just like a classification? It didn't have like a textual description, right? So you can imagine if you're dealing with a weak parser, the language model has to do a lot of work to make sure that it can hopefully answer your question. And you're kind of essentially going by luck at that point, that the model can just happen to look at the data so that it can infer the answer to your question rather than just, you know, looking at the data and answering it directly.
And by expense, I mean, the fancier the model, the more likely it is to make sense of this kind of loosely figured out text, right? I mean, the latest Gemini, the latest OpenAI probably does a decent job with this. Earlier models, not so much, or smaller models that you might want in local, and this. So there's options here, but this is not. I agree with you. This could use a little work, but it's pretty good, but not perfect yet.
Yeah, and I think that's a great point. Like a lot of people throw bigger models at the problem, and that's really like kind of the angle that they focus on, which makes sense, right? Because it's hard. Like as a data scientist, there's so many moving parts, and you have to focus on so many things. It's easy to kind of forget about this fundamental aspect, but if you are trying to level up your model, maybe you should be leveling up your parser for free instead.
Yeah, I like that.
Yeah. So we can look at another one. This is LlamaParse, which is way better. LlamaParse is the parser by Llama Index. And it's in markdown mode in this example. So you can see exam date, proc code, description, mod, B part, DX amount as these like sort of separated by vertical lines. This is in proper markdown format. And it's much easier to interpret. There's a new line that's kind of making things a little weird, partly because of the way it's in the table, it's in the slides. But you can tell, like, compared to the previous examples, this is much easier to interpret. And one would expect if you gave this to a language model, you'd get much better results.
Yeah, you do feel like this response is delineating the columns and the rows in Markdown. The technical component imaging performed by Dr. Vince Precise Imaging, I feel like you kind of can't see it because the red bars on the right side here, but they kind of garbled a little bit some of the information prior to the data in the table. But, this is probably pretty usable for a language model.
I completely agree. And then we have ours, which is also really good, at least in this particular example. We're a big fan of ours. We're trying not to make this the Ground X show, but we did pretty good on this. So when we extract tables, we apply like a vision model to identify the tables, and then we apply a variety of basically grounding strategies to extract this multimodal information into text. Some fancy data science magic, but it ends up being JSON, and the JSON respects the sort of format of the original table. So this is like, in my opinion, this is the most interpretable one. Take that with a grain of salt, I guess, because, but I like it.
I think we're attempting to do some things here that are a little different. If you look at the output here, there's a narrative summary. This is a JSON version of the output. You can get it in different formats. But this first, you start with a narrative version of the table, explaining to the language model what the data it's about to be given is about. This table contains details of technical procedures and billings by Dr. Vince at this business, and here's what you're going to find out. And then you lay the data on it. Then you tell it in a very kind of simple data format, breaking down that table, cell by cell, essentially. And we've found, at least, that when you explain to a language model, when you tell and then show, it tends to perform a lot better and understand what you're giving it. So we've designed it in this way. But this is pretty clean, so we're pretty happy with it. But
yeah, I'm proud. So we get a lot of different stuff, right? We get a lot of different formats from a lot of different parsing strategies. So even if they're extracting the same information, the way they represent that data can have a big impact, right? And we've actually seen this in testing. So Oh, this slide is a little out of date. I updated this, but we had some issues with the slides. Llama Index uses PyPDF under the hood. In this test, LangChain used Unstructured, and our technology GroundX uses our technology X-ray. But basically, we applied to the same documents, the same questions to different RAG strategies, and we got very different performance profiles. And we're under the impression, based on our analysis of this test, that the main difference between them for a lot of the questions was simply the parser that they used under the hood. Like the quality of the parsing is such a fundamentally important component. It really doesn't matter how fancy or advanced it is. Obviously, it's, you can do some fancy stuff, but if you don't have a really high quality parsing strategy as the foundation, then it's all kind of to the wind. Also, just to be clear, the Llama Index implementation here, it used PyPDF, the default, not LlamaParse. So we would expect a significantly higher performance in this particular test.
So the slide says it used Unstructured. It did not. It's a little bit of good. The LangChain Pinecone implementation did use Unstructured. The Llama Index did not use Unstructured in this test. It used PyPDF, which again is a little bit different than the slide we showed today, which is Llama Index's newest feature, which is LlamaParse, which seems to go well beyond PyPDF, and it seems to be, at least at first glance, very competitive with Unstructured.
And apologies for the slides. Maybe we can put like a little a little thing in there.
But I suspect if we ran this exact test again, that the Llama Index score would come up if we use LlamaParse as part of that pipeline instead of PyPDF.
Yeah, I completely agree. I don't know how much though. I think we're planning on doing that in the future. So I'm super stoked to do that.
Yeah, let's do it.
But also, so academia kind of agrees with this general sentiment though, that your parser matters. In this example, the previous example, there were different RAG strategies. So there were a lot of different things going on. In this example, in this little sort of table above this graph, they use the same RAG strategy across different parsers. So the only thing changing is the parser. And you can see, like, for some examples, there's a 10%, 20% difference in performance.
Yeah.
So
20 point difference, I should say, not percent.
Oh, is it? Yes.
Let's correct the data scientist from the guy who looks at financial numbers, not a data.
Yes. Yeah. But a significant increase in performance from between different parsing strategies.
For sure.
Which, again, it's kind of funny. People are, doing crazy advanced strategies for the difference in 5, 6, 7, 10% performance. And then maybe just completely switching the parser, you might get a massive performance increase.
The other thing I think it's really important to know is that these benchmarks are always good and useful to give you a sense of what's going on, but everything is so document specific. If you threw, you would see even within, I'm sure if you took apart what was the documents that were in that test, you would see the scientific document, which are typically very hard, actually, might do pretty poorly on any of these systems. But, give it a 10K or 10Q, and people are getting better at extracting those financial tables. So the documents do matter. You got to find the one that's right for what you got.
Yeah. So parsing is important. And it's important within the context in which you're operating as well, right? I think that general claim is 100% accurate. Like, the parser that you're using, it might work for your application, not someone else's. So you can't really just go out and ask a random engineer, what parser do you use? You really have to.
I mean, like I did. That's exactly the thing I did on Reddit. Yeah. Got it.
Yeah. And well, you can, and it's a good place to start, right? Like, what do you guys use? I like this. But there's a lot of work you have to do. And I recommend doing it because if you really are serious about building a RAG system, you're probably going to want to play around with a few parsers to get an idea of how they work and which one's the most performant for your specific application.
Right.
So the question becomes, how do you pick one, right? How do I do it? Well, I personally recommend a two-pronged approach, and we already did the first one, which is go off vibes. Always go off vibes at first. You need it's
vibes. Yep, very, very precise.
Yeah. I'm a scientist. But
scientist, dude.
But
that's probably the good job ever, by the way. Sorry to interrupt you, but if I could be a vibe scientist when I grow up one day, that job is chill. I'm Please promote me to vibe scientist one day.
That's why I got the hair. I'm trying my best. That's the life I'm trying to live.
You have it, man.
Pass your data through a bunch of parsers and look at them. Like I can't. You're like your brain is the most powerful model that exists. So passing your data through these through these parsers and looking at the results and thinking about it and really digging in and getting familiar, that's like the most fundamental, most important first step in any data science venture, is to just get your teeth sunk in on a problem. So I don't see a lot of engineers do this. Pass your data through a bunch of different parsers, see what you get. Super important first step. But obviously that's not the most scientific. You're probably going to find a few parsing strategies that seem good. And you, with your blind human naked eyeball, your caveman eyeball, whatever it is, you can't look at enough documents to be able to unequivocally say that this is the best one for my approach. So I think at that point, what I like to do is end-to-end testing. So you have your documents, you parse them in different ways, and then you pass them through your RAG system as it exists now, or whichever one you land on. But this is what's called an ablation study. You're changing only one component of a larger system, right? So you have your whole RAG approach, and you parse your documents differently with a few different approaches, and then you pass it through your one RAG system. Then you'll get a bunch of sets of answers. And kind of the most natural way to do this that I see the most often is you as a human answer those questions as well. So it's a labor-intensive process, to be completely honest. But you take your documents, and then you give your all of your parsing strategy RAG combinations a bunch of these questions. It gives you a bunch of answers, and then you as a human need to answer all those questions. It might be a few hundred of them. It's kind of a labor-intensive process. It takes some time, but I think it's very worthwhile.
There isn't, I mean, correct me if you think I'm wrong here, but in the new group of eval softwares out there that are being used for RAG, they don't really do this. They tend to eval a completion and a retrieval, and they'll ask, okay, we've got these retrievals. How well does the answer match the information given from the retrievals? But, that's at the end of the pipeline. You're already in deep trouble if something's wrong.
Yeah.
And for all the startup entrepreneurs out there, an eval on this would be really, really great.
Yeah, eval is tricky because the thing is, to do eval right now, at least as far as I understand the state of the art, it takes a ton of time. There's so much human work. You have to check every single question. And there are auto eval strategies that you can build on top of this. So if you have a bunch of documents, you can build question answer pairs, and you can design them so they're easily falsifiable, hopefully. And then you can ask your language model, your RAG system, the same question, and it'll get an answer. So then you have your answer, which is ground truth, and then the answer that the RAG system came up with. And then you can use an LLM to do that comparison. So you can think of building these QA pairs as an investment that you can use to build automated tooling on top of. But even then, it's still often labor intensive. You usually want to do at least some human eval still and keep a person in the loop, which is what we saw. We reviewed the Cragg paper, and that's exactly what they did.
Ultimately, you can't ask a language model to do its own homework. And if whatever system you're using cannot extract the information correctly from the document in the first place, which is kind of what this video is about, then no language model can assist you in determining if it's done that correctly. It's one of the problems of starting at the beginning of the pipeline. If you can't extract it, then you can't ask a language model to deal with it. So you can't use it to automatically do anything.
Yeah,
unfortunately.
And like you can speed it up. You can speed it up with auto eval, right? Like you can use language models to help you check. But
how would you check this? How would you check it if the language, to do an auto eval, you're feeding the language model something?
Yeah.
And the thing you fed it looks like it came out of whatever came out of PyPDF. What's the eval?
Yeah, so you have to start with the whole human part. So you have to start with generating your own answers. This is the answer that I declare is good. Then once you go through that effort, which is a long process, we know because we do it a lot. It's a long process to do that. But then once you have that is the answer, and then you have whatever the RAG system came up, then you can use a language model to help compare those. And that does speed things up tremendously. But it's very difficult to wash your hands of this. So I'm
This is
excited.
actually. Now this move from education to venting. This move from like how to do it to like, why can't it work?
Yeah, I mean, yeah, if someone can like make anything that can do this like significantly faster, I all the money I have, they can have it. But yeah, I think what was I going to say? I was going to say something. Anyway,
the slides. We're kind of getting into the home stretch and end-to-end eval, and what's the final word here? What's the conclusion that we can leave people with to take home?
Yeah. So this is what we did. We did this sort of eval system where we have QA pairs. That's how we generated these slides. So I want to get to the takeaway. There are a lot of ways to do end-to-end testing, right? You can also use ELO rankings if you don't want to do this QA pair thing. If you're dealing with like vibes, so like if you have documents and you want to mimic the style, so you don't necessarily have falsifiability built in, you can use different approaches, and then you can say, I like this one more than that one. I like this one more than that one. You can build something called an ELO ranking. Then you can use that to choose which parsing approach you choose. There's a bunch of things you can do, right? But at the end of the day, you really need to test the parsing strategy. And really the best way to do that, as we kind of mentioned, is I think end-to-end, where you give the entire RAG system a question and then you get an answer. And I think, I think that's pretty much it.
Yeah, if I could maybe summarize your summary, feels to me like parsing is hard, but absolutely critical to make RAG work. Some of the older extraction tools, maybe like a PyPDF or some of these other open source Python libraries, not always up to the task in modern RAG. Some of the newer technologies, LlamaParse, Unstructured, we're in there with our X-ray technology at eye level, are doing much, much better and able to interpret tables with much more fidelity, try to turn that into something that's either pure, say, JSON or JSONish, I like to say, like something that feels JSONic to the language models. And at the end of that process, though, you still need testing to figure out which one of these technologies is going to work best for your document set. And if you have a very diverse document set, you might actually need to employ a couple of them, depending on what you've got. And the last piece of that puzzle is for all the consultants out there, they may not even be devs, just people trying to consult on these projects. It feels to me like there's a big open space around testing because there's still a lot of human labor, like it or not, in getting this right. Thank you, Daniel. That was great. Much appreciated. And another RAG Masters is in the can, as they used to say. And this is a great one. I really appreciate it. We learned a lot about parsing. Do we know what's next week? We don't know what's next week. It's all right. There's going to be some.
Leave it in the comments.
Thank you for joining us on RAG Masters. We will see you next time.